This is the chapter 5, and in this section, in this chapter, we are talking about the friction. Friction is a contact force between the system that opposes the relative motion between them. So let's just start with an example. Say we are pushing a box with a force. So just assume here we are pushing, we call it applied force, and say there is a friction force. I call it F. Yes. Okay. Let's make a table. Say I push with a force of 1 Newton. The object is not moving, so the friction force must be 1 Newton. I increases push to 1.2 Newton. I push harder slightly. Object is not moving, so this means friction is still. Friction also changes to 1.2 Newton. Next, I push a little harder, 1.4 Newton. The friction will also be 1.4 Newton. I keep going like that. Say 1.6 Newton applied force, friction is also 1.6 Newton. Okay, so in this situation, I applied the force, but object is not moving. This means applied force and friction force are equal and opposite. So the object, in this case the box, does not move. Let's say I increases the force to 1.8 Newton. Then the situation is slightly different. It just begins to slide. The situation is just begins to slide. Okay. So the important point is that this friction force, 1.8 Newton, for example, in this case, this is the maximum friction force. So I will represent this by F S max. So object is not moving in this situation. So this friction is called static friction. Static friction. Okay. Let's draw force diagram of this situation. Okay. So the object or the box is represented by dot. Okay. The perpendicular force exerted by the surface is Fn. Force due to the earth on the object or the box is Fe, which equals mg. My push force, this is the push, the force I applied, say in this case is 1 Newton. Then the friction force will also be equal. This is Fs. So this equals that, and Fn equals Fe. If I push harder, what will happen in the force diagram? The vertical force, Fn, and Fe will not change. They still remain the same. I increases the push force. So now say 1.2 Newton. So length of error is slightly bigger. So it is, say, F equals 1.2 Newton. Then friction force is also bigger. I go like that. So this is Fs. This is also equal. So you can see here that friction force and applied force are equal and opposite. Here, these are symbols. Fn is the force exerted by Earth in the perpendicular direction. Fe is the weight of the object. F is the push. This is the applied force. And Fs is the static force. Okay. Under this situation, we can write Fs, which is static friction. So I will write like this: Fs is equal, less than or equal to mu s. We define this and Fn. So this mu s is called coefficient of static friction. Okay. So when the object just begins to slide, Fs equals Fx max. In our example, Fx max is 8.8 here. Okay. So under this situation, I can write Fs max equals mu s over Fn. So mu s can be written as Fs max over Fn. Okay. This is called the coefficient of static friction. Now let's consider what will happen if we increase the force beyond 1.8 Newton. Means the maximum value of higher the value of static friction. So for example, if my push force is, say for example, 2 Newton force, 2 Newton force, now object begins to slide. So object begins to slide. So in this case, the value of friction force will decrease, say for example 1.7 Newton. This is called kinetic friction force, right? So now similarly you can define Fk equals mu k over Fn. So here Fk is the kinetic friction force and mu k is the coefficient of kinetic friction. So be careful that kinetic friction and coefficient of kinetic friction are not the same thing. So similarly, I can write mu k equals Fk over Fn. So the equation of coefficient of static friction and coefficient of kinetic friction are very similar. Equation looks very similar, but you know that they are different meaning. So if you understand this concept, then I believe you can answer the practice question 1. But please explain your answer. Similarly, you can practice the problem practice number 2 and the practice number 3.